Our next thing in factoring is just to sort of give a general summary of factoring. We have this, I would call it like a toolbox of different techniques for factoring. We've got 6 formulas, we've got the greatest common factor, the grouping method, we've got the modified AC method, or some of you may prefer the AC method, either one. And so we have all these different tools, but the question becomes when to use them and how to use them. Okay, hopefully working on each of them individually, you've figured out how to use them. But now we're looking at more of a general, like when do I use one over the other? If I get a general polynomial, which one do I, which tool do I take out of the toolbox to use first? Okay, and so the first thing I would say as a general rule is always factor out a GCF first, okay? That should pretty much always be your general go-to. Soon as you see you've got a factoring problem, do I have a GCF? And if I do, pull it out. That will make everything else smaller. All the other terms will become smaller, the numbers are smaller, the exponents usually become smaller. And so if you pull out the GCF, everything becomes smaller, simpler, and easier to understand, okay? So do that first. So step 1 is always to pull out the GCF, if there is one. If there isn't one, skip that, okay? The second thing is to identify the number of terms. Once you've identified the number of terms, you can really figure out which of these other methods to use. So really, whether it's a monomial, binomial, or trinomial, or 4-term polynomial is important. Of course, a monomial, we're not really going to work on factoring. So number 2 is identify number of terms. Okay, so for instance, if you were to have a binomial, okay, with a binomial, there's a certain techniques you can, or certain tools you can use, I should say. We can't use grouping, we can't use modified AC, and we've already taken care of the GCF idea. Okay, so as I look down this, the only things that have binomials in them, I guess, are these 4 bottom formulas. You have the difference of squares, the sum of squares, the sum of cubes, and the difference of cubes. Okay, so a binomial is only going to factor basically using the GCF first and then one of these 4 formulas, okay? So we'll skip the GCF part. You're either going to use the a squared minus b squared. That shouldn't be that looks like a minus. Let's put a dot right there, okay. A squared minus b squared equals a plus b, a minus b. So we could use that one. We could say that a squared plus b squared is prime with the exception. Okay, and if it had the exception, well, actually, the exception is a GCF, right? We've already taken care of the GCF in the first step. So if after you've taken the GCF out, you still have a sum of squares, it's going to be prime. You've already pulled out the rest. So, yeah, okay, so we wouldn't really have to worry about that exception. Or you could use one of these 2 cube formulas, right? So you'd have b cubed plus, or a cubed plus b cubed. Or let's see, let's jot this one down. And so I guess you're really just trying to identify, which formula at that point things will fit into, whether it has cubes or squares, and whether it has a sum or difference, okay? Okay, so those are my binomial options. If you have a trinomial, all right, if you have a trinomial, then you're looking at first the modified AC method. Actually, no, let's hold that off till the end. First, you'd be looking at the perfect square trinomials. If you can get it to work with a perfect square trinomial, then you can skip the AC method altogether. Okay, so we first probably look at the 2 formulas, A plus b, oh, actually, let me write it in the reverse direction there. So it's a squared plus 2ab plus b squared. If you had a perfect square trinomial, it would be a plus b squared, and if you had the one with the difference, minus 2ab, you get a minus b squared, okay? So you could start with the two formulas, perfect square trinomials. If those don't work, then of course you want to try the modified AC method. Now I'm including in the modified AC method the situation where you have the lead coefficient of 1, which was a much simpler method. Sometimes I call that the shortcut, but it's really an example of the modified AC method. You just don't have the greatest common factor to divide out. So I'm going to include those in there. Modified AC. If you can't get one of the formulas to fit. And of course that could have lead coefficient 1 or not 1 in either of those. So you get the shortcut, the shorter method with the 1, a little bit longer method with the not 1, okay? All right, and that's it for trinomials. So those are the only options for trinomials. And then finally, if you have 4 terms, and of course we don't have a nice word to represent 4-term polynomials, so we'll just say 4 terms. If you have 4 terms and you've already pulled out a GCF, the only real option left is to try the grouping method, okay? So group it. Now remember, anytime you factor, you take a polynomial, factor it, the factors themselves could be factorable. And so you always want to continue factoring, sort of re-evaluating at each step. So if I factor a trinomial and I have 2 binomials as the result, the question is, are these 2 binomials then factorable? So I might start with a trinomial, factor it into 2 binomials, and then have to look at all the binomial options to see, does this continue to factor? You always want to see if you can continue factoring until the end factors are all prime, either linear factors or fitting into something like a sum of squares or some other trinomial that doesn't break down further, okay? So you always want to continue until you have prime factors. Let me run through maybe 1 or 2 quick examples. All right, so here's our first example. I've got 4 terms, so I already know right away I'm not going to be looking at the binomial or trinomial options, but I do need to look at the GCF. So I go first to the GCF. This does have a greatest common factor of 5 on every term. So I'm going to pull out the 5 first. I'm left with x cubed minus 4x squared minus 9x. Now you may have to run this one out on your calculator. 180 divided by 5 should be 36. So plus 36 is the start of the factored form. So once I've got it into a smaller form, I've pulled out the GCF. So all my terms are a little bit smaller. I'm going to look at grouping, because that's the only real option for 4 terms. And I'm going to take the first 2 terms together. Now I can't lose this 5, okay? Can't lose the 5. The rest of this factoring, I'm going to put in brackets here just to keep the 5 sort of separate. I've got, what, x squared as a common factor there, and then x minus 4. Here I have a 9 I could pull out. But I also want my signs to match up with the binomial signs here. So I want them to have a positive then a negative, but right now I have a negative then a positive. So I'm going to switch the signs by pulling out a negative 9. And that will give me x minus 4 as my leftover factors. Then I take this, I'm going to pull out the x minus 4, because that's common to both big terms. And I'm left with the x squared minus 9. Okay. Now, because I have all multiplication here, I don't really need the brackets to separate off the GCF at the beginning. And so I'm actually going to erase those because they're kind of redundant. Okay. And then I do notice that the 5 is prime, the x minus 4 is prime because it's linear. The x squared minus 9 is not prime because it follows the difference of squares formula. And so I can factor that further. It becomes x plus 3 and x minus 3. Hopefully you guys are getting the hang of those by now and can see those pretty quickly. And then the other two factors must come down and be included in the final answer. So my final answer has 4 factors in it. I did utilize the difference of squares formula, the grouping method, and a GCF. So we kind of went through all those different things. At this point, none of these factors are then factorable. They're all prime, so we're going to leave this as our final answer to this problem. Okay. Maybe I'll pick up one more example here. Let's try 27x squared plus 36 xy plus 12y squared. Okay, so this one's going to be a bit tricky because there's 2 variables. That's okay though. First thing I notice is that 27, 36, and 12 all have a common factor of 3. So I'm going to pull that out first. Let's factor out a 3. I get, divide 27 by 3, I get 9. So that's 9x squared plus 12xy plus 4y squared. Okay, so now I've got a trinomial. And my options for trinomial are the AC, and these two, the perfect square trinomial formulas. This actually fits a perfect square trinomial. I noticed that because I noticed my first 2 terms are both perfect squares. First and last term. In the middle term, if I imagine taking the square roots of these, 3 and 2, multiply and get 6, and double it, I get the 12. So this middle term is double the product of the square roots on the ends. So this does fit. Which one is a plus? So it's this first perfect square trinomial formula. So I'm going to go ahead and break this down using that formula. When I take the, when I factor the perfect square trinomial, I'm going to get a single factor squared. And in that factor, I'm going to have a plus because my middle sign is plus. And I'm simply going to take the square root of the 2 ends. So the 9x squared becomes a 3x, and the 4y squared becomes a 2y. The extra variable in there doesn't really affect anything. I just have to make sure I have it on the last term because it is squared on the end here. Now if I were to remultiply 3x plus 2y times 3x plus 2y, I will simplify to get 9x squared plus 12xy plus 4y squared. And so this is my factored form using both the GCF and our perfect square trinomial formula. Okay, and so you can kind of see that some of these are going to be a multiple step process where you do some factoring and some more factoring. Some of them you may have to do more than 2 steps, maybe 3 or 4, but you're continuing to factor as you go down. Again, using the strategy, trying to identify greatest common factors at each step first, and then identifying the number of terms and which formula to use, or which of the methods to use. Okay, hopefully that helps, gives you a general strategy to approach any factoring problem.